All right, today we are talking about the recursive formula for arithmetic sequences. You will recall that yesterday a sequence is a set of numbers with a pattern. We talked about two kinds of sequences yesterday, arithmetic, where we add, and geometric, where we multiply. Today we are only going to be talking about arithmetic. We're going to be using a recursive formula. Now here's the thing about the recursive formula for anything. Recursive by definition means that you have to use the last answer to find the next one. The analogy I like to use for this is stepping stones across a stream. You can't go from one edge all the way to the other edge of the stream. Instead, you have to hop along on each little stone. Now, mathematically, these are not too difficult. However, it does require a bit of writing. I'm going to write this really big at the top. Write it out. The most common mistake on this next assessment is students do not write enough. Yes, I know it's annoying. Yes, I will mark it wrong in the assessment if you haven't written enough. But the process is very straightforward. You'll notice the recursive formula is already written out for you. We have a1 is the first term, and a sub n is equal to a sub n minus 1 plus d, where d is the common difference. So let's see what this looks like in practice. Our first example, we already have the recursive formula written out. We are already told what our first term is. Our first term is 10. We start at 10. The first one, you simply just have to write 10. Now from here, to find each next one, we have to change the number. So for example, a sub 2. 2 is n. So then we have to replace 2 for n there. So it's going to be, I'm going to zoom in a little closer. A sub 2 minus 1 plus 5. Notice, instead of n, we replaced it with 2. Now let's go ahead and do some quick math. 2 minus 1 is equal to 1. Now what is a1 equal to? 10. So that's the same thing as 10 plus 5, which is equal to 15. Now I know there are many of you that could have done that all in your brain. This is not an exercise of doing it in your brain. It's showing me that you know how to do it on the paper. Make sure you write out the whole step. Now, like I said, we have to use the previous answer to find the next one. So let's go ahead and do that. A sub 3, instead of n, we replace it with 3. So that's going to be the same thing as a sub 3 minus 1 plus 5. 3 minus 1 is equal to 2. A sub 2 plus 5. Now what is a2 equal to? Well, 15. Which is 20. Let's go ahead and do our last one. A sub 4. So instead of n, we're going to replace it with 4 both places. A sub 4 minus 1 plus 5 is going to equal a3 plus 5. Now what we already know what a3 is. A3 is simply 20. So we can plug that in, giving us 20 plus 5 is equal to 25. We are using the previous answer to find the next one. Yes, it is a lot of writing, but mathematically, fairly straightforward. So let's go ahead and look at our next one. We first need to write the recursive formula. Well, the first ingredient of the recursive formula is always a1. Always write out the a1. So in this case, we start at 36. So that is our a1. Now, let's figure out what our common difference is. How do you go from 31 to 27? Well, you subtract 9. How do you go from 27 to 18? Well, we subtract 9. How do we go from 18 to 9? Well, we subtract 9. So in this case, our common difference, each time we are subtracting 9. So let's go ahead and set this up so that it looks like our recursive formula here. So a sub n is equal to a sub n minus 1 plus negative 9. If we wanted to, we could erase this and replace it with a minus sign, just like so. Now from here, we can go ahead and write our recursive sequence. A sub 1 is equal to 36. Now let's just verify this. Let's go ahead, we got to do A2, A3, A4 to find A5 like it asks for. So let's just go ahead and write out our formula for each time. Yes, it is annoying that you have to write this all out, but a bit of writing isn't so bad when you know what to do. So let's start with A2. A2 is going to be the same thing as A2 minus 1 minus 9, which is the same thing as A1 minus 9, which is equal to 36 minus 9, or 27. A3 is going to equal A3 minus 1 minus 9, which is equal to A2 minus 9, which is equal to 27 minus 9, is equal to 18. A2 being what we figured out in the previous answer. Let's go ahead, figure out our last one. A4 is going to equal A4 minus 1 minus 9, which will be A3 minus 9, which is 18 minus 9, which is 9. I'm going to take my last work and just kind of squish it down. I'm going to give you permission to skip one of these steps. I trust all of you are smart enough to do this little subtraction problem in your brain. So we can go ahead and skip that. Let's just go straight to A4 minus 9 is equal to 9 minus 9, which is 0. So term 5 is equal to 0. Now, sequences can look a couple different ways. So let's go ahead and talk about a different kind of way that sequences can look. All right, the number of toothpicks on each figure. So on the first one, there's 4. On the second little Christmas tree, we added 3 more toothpicks. So that one's going to be 7. This one's going to be 10. The next tree is 13. We have to figure out how tall the 5th tree would be. Now, I'm sure all of you could draw this. In fact, I will just go ahead and do so. It's an extra little triangle on top. There's 16 toothpicks. But let's go ahead and verify using our formula. Is this something you'll have to do in the assessment? Absolutely. Make sure you write it all out. Okay. So in this case, our A1, our first term, was 4. And then our common difference, in this case, is plus 3, because we are adding 3 on each time. So the full version of our recursive formula is a sub n is equal to a sub n minus 1 plus 3. So let's go ahead and write out our formulas. A1 is equal to 3, we know that. A2, the second term, is equal to 3, A1 plus 3. Oh, I made a mistake, didn't I? That first term is actually 4, which is equal to 4 plus 3, which is equal to 7. The third term is equal to A2 plus 3, which is equal to 7 plus 3, which is 10. The fourth term is equal to the third term plus 3, which is 10 plus 3, which is 13. Last term, the one that we added, is going to be equal to the fourth term plus 3, which is 13 plus 3, which is equal to 16.